Now that you've had a chance to explore the dot product yourself, we'll go a little bit more formally through the geometry of the dot product and its properties. So if you filled out the interactive demo, you should have seen this plot. So this already begins to tell you that the dot product between two vectors depends on the angle between them. It differs based on where I am in this circle around the origin, and the length of at least one of the vectors. It changes along these lines. And that's true, and we can formalize that. I'm not going to provide the proof of this, but it will be in the bonus if you want to check it out. So the dot product equals the lengths of each of the vectors multiplied together, and then multiplied with the cosine of the angle between them. So you can see that this formalizes what you intuited from the demo, that the dot product depends on the lengths and the angle. And this has a couple interesting effects for us. If the dot product is 0 between two vectors, you know that those two vectors are perpendicular, because the angle when two vectors are perpendicular would be 90 degrees, which makes the cosine of that angle 0, which makes the whole dot product 0. And that's the only time it is. So that's already something helpful that you can use to also understand what's going on in higher dimensions when you can't just look at what's happening. The dot product is the highest when the angle is 0. So when the vectors point in the same direction. And the dot product is lowest when the angle is 180 degrees, meaning that the vectors point in opposite directions. So those last 2 points taken together mean that, at least if you hold the lengths of the vectors constant, the dot product is kind of a measure of similarity of two vectors. It's really telling you it's highest when they're the same direction, and it's lowest when they're opposite directions.